Hey everybody, welcome to Bill Sky, the Assembly Guy, and what we're going to do in this video is it's going to be a continuation of our conditional branching video for ARM, and this one is going to be on how to implement if statements as if they were from C or C++ or even Java, and really from C or C++, and how the compiler might actually generate the machine code in assembler or directly into machine code when you've got those type of if statements. So let's get going. So I've got a new project out here, and I'm going to go ahead and edit this with Genie. And the first thing we want to do is we want to create some variables because, of course, if statements normally have variables. So I'm going to create variable A. That's going to be a D word. Now this is 64 bits, so it's going to be 8 bytes. We'll give it a value of hexadecimal 10. For variable B, we're going to give this hexadecimal 20. Var C, give that hexadecimal 30, and then we're going to have a var D or just 0, hexadecimal 0. Now this video is going to be an awful lot like the x86-64, but there are some real differences when you're dealing with ARM processors. In x86-64, in a comparison statement, you can actually go directly to the memory location, but in ARM, you can't. You always have to put the address of the memory location into a register, and then you have to dereference that memory location. So, and that's what we're going to do today. So, I like to put in a lot of comments in my code to help me understand what's going on. So, okay, so there's our variables. Now let's go ahead and start a very, very simple equality test. And let's do this as signed. And the way this is going to work, I'm going to say if var A is equal to var B. Now this is as if it's C++. I'm going to say var C is equal to 22. Else, I'm going to say var C is equal to negative 22. So how would we do that? I even like to have my comments spelled correctly. So how would we actually do that? Now what I like to do is I also like to put into my comments the variables and what registers I'm going to use in the assembler language to contain that variable. And this is a little trick that I've been using for years, and it really helps my code get back. It really helps my code. It helps me understand what I'm doing in my code. I really should stop typing when I'm trying to explain something. Okay. So let's go ahead and put that there. Okay. So what this means is that var A is going to be stored in x0. Var B is going to be stored in x1, and var C is going to be stored in x2. And in our if statement, you can see all of those variables used. So I know exactly what I'm going to do in my if statement. So I'm going to assume that the condition var A equals var B is true. And by assuming that a true or false condition is true or false, by assuming that the if statement is going to be true or false, you're reducing the number of jumps, or in this case, the number of breaks you're going to have. So I always like to do that. So what I'm going to do is I'm going to move into x2 the immediate value of 22. Now, why am I using x2? Because x2 is going to contain our var C. So instead of storing it directly into memory right away and having multiple memory accesses, I'm going to use the registers for now. And this is a very big theme in ARM programming. So let's go ahead and put var A into x0. Let's put var B into x1. And then we can actually start doing the compare. So the way that you move memory into a register, and I know I've gone through this before, but let's do it again. I have to load the register. In this case, x0. I have to load the variable address, var A address, into x0. And then I can load the value of the dereference into x0. And we're using x0 here both to contain the register and then later to contain the value. No problem doing that. It works out great. So let's do the same thing with x1, and x1 is going to contain the address of var B, and then x1 is going to contain the dereferenced version of x1. So now x0 contains var a, x2 or x1, x0 contains var a, x1 contains var b. You see how easy it is to get mixed up here? And that's why I always have these variables specified in my comments so you can keep track. All right, so now we've got our data located into our registers. Now I'm going to compare x0 with x1. So I'm going to do the comparison. Now, because we are simply looking at equality, it doesn't matter if it's signed or unsigned, so we're going to use the same branch. I'm going to branch if equal if else 1n. So what that means is that if they're equal, I've already done the assignment of x2 with the value of 22, which you can see here. I've already done that. So why continue? I don't have to do it again. I'm going to leave the if statement. And let's go ahead and put the label there. If they're not equal, then I want to move into x2 the opposite or the false condition. And now I'm at the end, so then I'm going to load into x0 the address of var c. I'm going to then store x2 because x2 is what contained our result, the true and the false. I'm going to store from x2 into the dereferenced x0, which is var c. And you really need to put some comments here. Assume true, so x2 will contain 22. Load var a into x0. Oh, please put in comments, please. Load var b into x1. And the comments can even be more specific than this. Do the if. If equal, we already assigned the result in x2. Otherwise, not equal. So do the false condition, or the false result, I should say. And the if, store our result into var c. Now at this point, I would ask my class, do you have any questions? The cool part for you is that you can put this on hold and you can take a look at the code, and you can even go backwards in the video and take another look or listen to what else I said. So if you compare this with the x86-64 code, this is probably 3 or 4 lines longer because you've got to load the register and then load the dereferenced address into the register. But from a speed point of view, I think this is actually faster than x86-64 because it's a RISC processor. It's a reduced instruction set computing processor, and they have a tendency of running a little bit faster, or sometimes a lot faster. But the code is basically the same. The logic of the code is basically the same. Okay, let's do another one. This time, let's do one with an AND. I really like those. So I'm going to do a complex AND test, and we're going to keep this with signed. And what we're going to do is, let's go ahead and, I don't know, what is, the assumption is going to be that I think x3 will be our result register. So I always like to put that information in there. All right, so let's put in what the if statement's going to be. The if statement is going to be if var a is equal to var b and var a is greater than var c. Now, one thing to remember here is that when you're dealing with an AND, if either one of them is false, why continue with the if statement? Just end the if statement, have done with it. We don't have to worry about it. So let's put in what we're going to do. We're going to say var d equals 33, else var d equals negative 31. I'm not sure why I said negative 31. It doesn't matter. Okay. So once again, if either one of these conditions are false, why ask the second one? So if this first one is false, why continue? Just leave the if. Now, if that's not false, if it's true, you have to check the second one. And that's okay. That's what we're going to do. All right. So I'm going to do the same thing I did up here. What I'm going to do is I'm going to copy these comments. And I'm going to document here what my registers are going to be. var A is going to be contained within x0. Var B is going to be in x1. Var C is going to be in x2. And let's go ahead and say int var D, that's what we had up above, that's going to be contained in x3. Again, I'm doing this to document my code, so as I'm coding it, I don't get mixed up. It's so easy to get mixed up. So let's get the data in there first. So I'm going to load into x0 the address of var A, and then I'm going to load into x0 the dereferenced x0, which will actually move the data out of var A into x0. Let's do the same thing with x1, but we're going to do var B. You can actually get used to this pretty quickly. And then we're going to do the same thing with var C. Now the reason we're doing this is you have to do it in ARM processing, and also we're going to be doing all of these variables in the comparison. So we have to do this. There's no choice. Now what x0 am I going to use? Oh, so var C is going to be an x2. Okay. You see how that can help? I'm just telling you. All right, good. So we've got var A, var B, and var C on our registers. Now, like I said in the equality test, in this complex test, I'm going to assume that one of those two conditions, this condition is false or this condition is false, I'm going to assume one of them is false. So what I'm going to do is I'm going to move into x3. Now why x3? Because x3 is going to be our destination register. I'm going to move into x3 the false condition of -31. So I'm going to assume that that is going to be negative. And then I'm going to start my comparison. So I'm going to compare. Now which ones do I want to compare? Var A and var B. That's x0 and x1. So I'm going to compare x0, x1. I'm going to compare those. I'm going to branch if not equal. So if they're not equal, that means the first condition in the complex if is false, so why even continue? So I'm going to say branch if not equal to if else to end. Let's leave the if statement. Okay, let's just leave the if statement. Now what happens when we leave the if statement? We want to, well, let's do that in a minute. Okay, so if they're not equal, then we leave the if statement. If they are equal, then the next line is going to be executed, and now we have to do this. So we're going to have to now compare. Now which registers are we going to compare? Var A is x0, var C is x2. So we're going to compare x0, x2. Are you seeing the benefit of doing these comments? Boy, I hope you are. And I'm going to say branch if less than. Now we're using less than instead of high or low because we're dealing with sign numbers. So if var A is less than var C, now actually I think we have to use less than or equal to, don't we? I think we have to use less than or equal to. Now why are we using less than or equal to? Because if the opposite of greater than is less than or equal to, right? Because var A is not greater than C, so it must either be equal to C or it must be less than C. So we're going to say branch less than or equal to, and I'm going to say if else to end. Why am I doing that? Because this is false, and we've already assigned our destination register -31. There's nothing more to do. All right, now, if it isn't less than or equal to 3, then we want to do the false condition, which is -31. So we're going to say move into x3. -31. And I believe we're pretty much done with the condition portions. Now, what do we do in the if else? We have to load our register, or the address of var D, into x0. We have to do this assignment. We have to actually move the value into var D. So we load that in, and then we store x3, which was our destination register, into the dereferenced x0. And I'm not going to go through and type in all the comments here for you, but you can see just how important it is to type comments. You can see how important this was right here to keep my brain straight as what it was I was doing and what registers I was going to be using. So please comment your code, and let's move on to the next example. So the next example is I want to do a complex OR test. And let's do this unsigned, just so we can get some practice. Now, before we do that, I haven't actually built anything. So I actually have some errors here. What did I do here wrong? Did I put I think I put a period instead of a comma. Yep, that was it. So it's always good to make sure that you build as you're coding to make sure you don't have any errors. And it looks like I did not put my... Oh, I didn't spell this correctly. There we go. Now, one thing I also like to do is I like to indent code that belongs to a certain label. So that makes it a little bit easier to view. It's almost like an if statement. You can even do it like here. And it's not going to make your code any less readable. In fact, it's going to make it more readable to do that. Okay, so important to do your builds from time to time. All right, so let's do a complex OR statement. So I'm actually going to copy most of what we've got here from the previous AND, so I don't have to just type it all again. All right, so we're going to use the same. We're going to use the same register. See, this is the benefit of doing these comments. And let's go ahead and put in some different conditions here. So I'm going to do an if statement. If var A is less than var B, or var A is less than var C, we're going to say var D equals var A. Else, we're going to say var D is equal to var C. So again, you see all these variable names. This is invaluable, putting these cross-referenced comments up there. Now, just like with the AND, we're going to do two things. We're going to make an assumption, but also, if either one of these conditions are true, unlike an AND, if either one of them are true, why bother with the second one? So if the first one is true because it's an OR, why ask this question? There's no reason to do it. We're just going to ignore it. Okay, so let's go ahead and start loading up our registers. We're going to load x0, the address of var A, then we're going to load x0, the dereferenced address, which is going to get us the value. Let's load into x1, var B. I'm looking up here at my comments to make sure that I've got my registers correct. And we have to do the same thing with var C. That was x2. Yep. If I hadn't had that comment, I would have had an error there. Okay, so what am I going to do here? I'm kind of looking at my notes here. So x3 is going to be our destination. So I could go ahead and initialize x3 to 0. Actually, is that right? Yep. So I could initialize our x3 to 0. I could assume, well, let's do this. I have some values here. Let's put in 30 here. Yeah, I didn't quite copy and paste what I had done earlier. Okay, so I'm just setting my values to kind of get my act together. So let's assume that there's going to be a true condition here. So what I'm going to do is x3 is going to be our destination, and let's assume the true condition is going to happen. So we're going to say move into x3, which is going to contain our var D. We're going to move into x3 var A, which is actually in x0. We're going to assume the true condition. And I'm going to put a comment here. Assume the true condition. So we're going to put var a into var d. Var a is stored in x0, so you can see it there. Var d is in x3, so we're going to put it in there. So we're going to assume that true condition. Okay? Now we're going to compare x0 with x1. We're going to do this part of the if statement. All right? Now this is unsigned. So we're going to say branch if low. So if var A is below var B, we're going to branch because it's true. We're going to branch out of the if statement because we already did this assignment right here. So we're going to branch low to if else 3 end, and let's create that. So we already did this assignment in x3, and remember, x3 is our destination register. So that's true. The first part is true. First half is true to the left of the or. So why even ask the second one? Okay. So now if it's not true, if it's not below var b, I'm going to compare. Now what are we comparing? We're comparing d and c. D is x3. Oops, we have a problem here. D is x3. Oh no, I'm sorry. I was looking at the assignment. Oh. So imagine if I didn't have these commented. So we're comparing var A and var C. We're going to be comparing x0 and x2. So we're going to compare x0 with x2. This is the right part of the or. Let me make this a little bit bigger so I can keep track of my code, my comments. And if that's true, if it's below, so if x0 is below x2, I want to jump to else, if else 3 end. Otherwise, if it's not, this is false. So if this is false and that is false, then I want to move into x4, x2. Now, why am I moving x2 into x4? Is because we're moving into var D, var C. Var D is contained in x3, var C is contained in x2. And then we say move or load x3 comma var D. Now we can overwrite x3 because we're now done with everything. Let's make sure. Oh, nope, we have a little bit of a problem here. What we're doing is we're using x3 as our result register. We might want to change that to x4. And the reason is that we used it in a comparison. Oops. So let's change that to x4. And we did that there. So we're okay. All right. So we load the register, the address of var D in x4, and then we store x4 or the value of x4 into x3. Now let's look at this code a little bit closer. I didn't put a lot of comments in here, so I'm a little bit screwed up. So get our var A value. So I think these comments will fix it up. Get our var B value. Get our var C value. Okay, so we're going to assume the true condition. We're going to use x4 as our result register. So the true condition says that var D is assigned var A. Var A is stored in x0, so we put x0 into x4. So that's cool. So now let's do the var A less than var B. True, so exit the if statement. Now we put x0 into x4. Let's make sure we're storing x4. Okay, that's cool. We're storing x4. However, this one's wrong. And you'll see why in just a moment. Okay? Let's do the second. We're going to check var A less than var C. True. So exit the if statement. false, both. So assign var C to var D. Now remember var D, oh, see, there's our, yep, so var D, oh, so our temporary, not that, so our temporary, whoop. See how confusing this can be? So assign var C to temporary register. Remember, X4 is our temporary register, all right? And now we're done with X3, so put var D address into X3, copy our result into var D. Whew, man, so I'm telling you, if I didn't have those comments, I think I would just, I'd be going crazy. So we put our values into our three registers. Var A goes into X0, var B goes into X1, var C goes into X2. I'm not doing a comparison of var D, so I don't have to put that into a register. Then I'm going to move X0 into X4 because X0 is var A, and that's what this is. Var A goes into var D. So X4 will be our temporary register. Now this is a little bit confusing because I could put I put X3 there, so I'm going to take that out of there. Just so I think that's what confused me during this development. So I'm going to move var A into the temporary register. Then I'm going to compare X0 and X1, which is var A and var B. If X0 is less than X1, I'm going to branch here. I'm going to get the address of var D, put it into X3, and I'm going to put X4 into that dereferenced var D. And that's because we used X4 as our temporary result register. Now, if it's not below, we have to check X0 and X2. That's var A and var C. That's this one right here. If var A is less than var C, we're going to do the same exact thing. Otherwise, we have to move into X4, X2, because X2 contains var C. Holy Moses! But I do believe that that's correct now. Now, something that you can do in x86 that you just cannot do in ARM is I can't do something like compare X0 with dereferenced var B. You can't do that. It won't build. And actually, that's kind of surprising that did build. I'm not sure what the result will be, though. I'm not sure if that will actually... I don't think it will, but I'm not sure what that's going to do. I don't think it's valid. The assembler doesn't tell me it's a problem. In fact, I remember when getting ready for this presentation, I tried that, and there was some strange value in that it returned. I'm not sure what it's going to do. So the way that you do this is you load your variable values into the registers, and then you just do the comparison of the registers. Just because it assembles doesn't mean it's actually correct or it's actually going to work. The machine code is actually valid. And some people, well, but what about dereference the address? Will that work? Well, that doesn't work either. And that actually gives you an assembler error. So those are complicated or complex if statements in ARM assembler. One nice thing about ARM is that there's so many registers in the ARM CPU that you could have a really long if statement, 10 or 12 conditions with 10 or 12 different variables. You could load them all into registers and you wouldn't have to worry about it. That's one of the benefits of the ARM processor. So with that said, hope to see you at the next video.